All right, welcome everybody. Thank you all for joining today. Just jump right into it. I have Ryan Sieve here, who is going to be doing our presentation today. Ryan is the CTO for Accounting Seed, the company I work for, and he's actually my boss. But I won't hold that against him. So we'll go ahead and hand it off to him. In terms of, we want this to be an interactive session. So if you have questions, please feel free to, to interrupt. If you're having trouble understanding something, please, feel free. I will also be monitoring the group chat. So if you have any questions and you don't feel comfortable wanting to speak up, please, by all means, post something in the chat and I will monitor that. So, okay. All right. So with that, I'm going to turn my camera off and I will let Ryan take it over.
Sure. Thank you, Jason. I'm going to try to share my screen here and hopefully you guys can see this. Can you guys see this okay? Yes, maybe, possibly, hopefully.
Yep.
Yep. Looks good.
That's great. Well, I know it's Friday, and I think you guys are all gluttons for punishment to join a crash course call on a Friday here. So thank you for taking some time out. I know life is always busy, so glad to have a little bit of time with you today. Purpose and intent of the session today is really to give an overview of the Lightning Component Framework. Whether you're coming from Visualforce, coming from another technology that's not Salesforce related, there's sometimes that barrier of just how do I get started, right? And so the intent of today's session is really to give that sort of functional crash course of what is Lightning Web Component, how does it all work, how does it tie together? And the objective today is to really help you build a path to acquiring or mastering this skill set. There's tremendous resources out there on Trailhead, a lot of great blog articles, all kinds of things out there that you can take advantage of. But today is just trying to help jump in head first and equip you with some basic knowledge to get things going on this journey. Make no mistake, this will not be a super badge. There are super badges that you can pursue in support of this. So today, again, as Jason was saying, is intended to be pretty informal. So feel free, send some questions in the chat, interrupt if you like, and we can go from there. I'll try to leave a little time for Q&A at the end, but if something comes up in the middle of the presentation, feel free to jump right in. Who am I? I think Jason already kind of did my introduction. My name is Ryan Sieve. I'm CTO here at Accounting Seed. Big believer in Salesforce certifications, so go for them if you'd like that. I've been doing Salesforce development work for a little over 17 years now. And prior to joining Accounting Seed, I was a director of technical architects while I was at Salesforce. It's not all code for me. I am a proud father of 5. Life is very busy, and you can probably see how my hobbies align to being a father of 5. I love coffee, as you can imagine. Sleep is hard to come by sometimes, so that helps. I love cooking. I feed an army every day, quite literally in my house, so I better enjoy that as a hobby. I live in Kansas City, so barbecue is a big thing for us here, as well as sports. Big Pat Mahomes fans here too. Sorry, Jason. I know.
That's okay. We're coming back. Don't worry. We're coming back.
Yep. And then just the great outdoors. Love to kayak, hike, ride bikes, all the things active. So I would be remiss if I didn't put a shameless plug in for Accounting Seed. Accounting Seed is a native accounting financial management application built on Salesforce. You can find us on the App Exchange. Salesforce has become such a huge backbone for so many companies, whether you're doing sales, service, support, field service, revenue management, whatever it is. Accounting Seed is really there to be that financial backbone. So when you mix your operational financial data together, some really, really special things start to happen for companies, especially as you think about analytics and AI and all kinds of things. So here's my shameless plug. We've got over 50,000 global users. We've been a partner for over 12 years. Accounting Seed is a pretty cool app. All right, with that out of the way, let's talk about the agenda. We'll do an overview of the LWC framework in general, just kind of a hello world as far as that goes. As we talk about the framework, we're going to look at some demos and examples. Again, feel free to jump in with questions or comments as we go through. I think from there, we'll go through some design patterns, and the design patterns are going to kind of go beyond maybe what you would run into with Trailhead, and just some general best practices, things like that, in using those components. And then I've got some resources linked at the end of the deck. I will share the deck with Jason, and he can distribute that with the team. So there's some links in here that you might find interesting as a resource. So feel free to dig into those after the fact. Okay, assuming we have no questions, Jason, I'll just go ahead and dive right into the framework overview. Okay, well, LWC, I always like to lead off with this. It's just JavaScript. That's all it is. It's just JavaScript. If you've done web development in the past, don't be intimidated. It's just JavaScript. Now, JavaScript has evolved a little bit over the years, so maybe you wrote some JavaScript with Visualforce or some other technology. There's some enhancements that have been brought on with JavaScript. We're going to talk about those as we go along here. But if you're new to JavaScript, just a couple key things to call out here. I don't want to spend a ton of time on this, but I think this will help put things into some context. And then this would be a good thing for you to research and reinforce on your own time. One key concept here is that JavaScript is inherently single-threaded. If you've worked with JavaScript in the past, you may have heard of callbacks or promises, async, await, things like that. I did want to give just a quick overview. I think a lot of times developers fight bugs in JavaScript, and oftentimes those bugs are really just timing issues. So when you have something that's running in the call stack in JavaScript, remember it is single. Team, if you could mute, unless you have a question, feel free to jump in with questions, but just to kind of minimize background noise. But if you have an asynchronous task, let's say that you make a request to the server for something, those types of things fall into the task queue, which frees up that thread to work on other stuff. And then the event loop is pulling things out of the task queue as those things resolve, and they put it back into the call stack. So a lot of what we'll talk about here is just kind of managing those threads and that event loop. But again, something to take a look at if you're not very familiar with JavaScript. This is a really key concept. I did link a really great blog article that I found here in the presentation. This is an article that has some animations and kind of a video that goes along with it. Does a really great job of explaining JavaScript in the event loop, which is a key concept. Again, promises, async, await, they're kind of managing those asynchronous tasks. The more recent annotations of JavaScript, ES6 and beyond, use the concept of classes, which you're going to see in the Lightning Web Component Framework. And they also use decorators, which are kind of like applying a set of pre-built behaviors to things. And again, we're going to talk about that with respect to the Lightning Web Component Framework. Last thing I'll say on this, this is a portable skill set. So if you're coming up on JavaScript, I think it's interesting and helpful, of course, with your LWC journey. But this is a skill set that you can take to other technologies as well. So if you ever get pulled into Node.js, you want to do things with the Salesforce CLI or the Oak Cliff framework that sits behind it, or just generally any other modern web components are using this, React, Vue, etc. It's a good skill set to have in your back pocket for many reasons.
Before we move on, we did have one question. If you could give me the URL there for that blog, I'll post it in the chat for everybody.
Yeah.
Or you could just, yeah.
Yeah, let me see. I was finding this the other day. So here is the article.
Perfect.
Hopefully
Thank you.
And again, you'll have this in the deck with the link there as well. All right, let's see here. You guys still see the screen okay?
Yep, looks good.
Okay, great. Okay, a couple quick things. Generally, as you know, Salesforce has a metadata configuration that pretty much sits behind everything. Some key things I wanted to call out for this would be the targets for these web components. You can set these components to run or be available for app pages, record pages, home pages, the tabs, utility bar, the list goes on and on. So if you want to configure your component to work in the context of a specific aspect of Salesforce, again, like a record page, there's some special things that happen with that. And we're going to get into that a little bit more. Whether or not the component is exposed, obviously, if you want to expose this component to admins to work into an app builder or page builder, you'll need to set that flag there, as well as at least one target. And then this one is oftentimes overlooked. You can actually include an SVG icon for your component so that when you see it in the list of components available, you can have an icon associated to it. So whether you're building a component for your company and you'd like to put your company logo in there to help you know that this is your company's custom component, or you're building software and you're packaging it and you want to put your software packages logo on it, that icon file is very handy for that. Last thing here is there's different component types. There's UI components, which I think are pretty self-explanatory. LWC did bring in the concept of a service component. A service component, just like a service class, can be imported with reusable functionality so that you don't have to rewrite that functionality over and over in different components. And a modal, again, self-explanatory, but within the Lightning app, you can present modals as a specific type of Lightning component. All right, guys, last thing on the framework, then we're going to start to get into some real things, some code and the demos. I did want to talk about the life cycle, and I think this is important to call out, especially with respect to that event loop that we were talking about earlier. When a component is created, it goes through this life cycle here. And you'll see much more detail on this in the Salesforce documentation, but I tried to kind of create a basic version of this for the sake of discussion today. Anytime a component is included in the page, the constructor for the component is called first. Then there is a connected callback function that's invoked. Any time that you have child components that are included in a parent component, this process will repeat constructor and connected callback for any child components that are in that hierarchy. And then as each component renders, a rendered callback will be called from the very most child component first, and then all the way back up through the whole chain. Ultimately, where the rendered callback is invoked for the topmost component that was created. If the component's destroyed, then disconnected callback will be invoked. But I think this is important because oftentimes components have some task that needs to be carried out right away, like fetching data or setting defaults, things like that. So that connected callback and the constructor become really important pieces of that journey. If we have some time, perhaps at the end, we can get into this, but debugging, as we all know and love in any kind of coding, there are ways to enhance or improve your debugging in the Lightning Component Framework itself. There's a debug mode that will present to you a much more easily readable code format as opposed to everything kind of shrunken down. So turning that on, you'll take a bit of a performance hit, but your sanity will thank you. And then we can also talk about the browser console, adding debugger lines and console.log, much like you might be familiar with doing in system.debug with Apex. Okay, enough of this. On to the actual framework itself. There's three main decorators that we're going to talk about with respect to the Lightning Web Component Framework. Track, API, and wire. And we're going to walk through some demos that help demonstrate the behavior here. So the first decorator that we're going to talk about is track. And the name kind of indicates what it's doing is it's tracking changes to a variable. And then it's making the UI react to those changes, whereby any change to a tracked variable will immediately reflect itself in the UI. This has kind of evolved as the Lightning Component Framework has evolved too. And in its current state, if you have a primitive variable, like a number or a string, it's automatically tracked. But if you have a complex variable, like an object or an array or some combination thereof, you do still need to annotate it with track. So with that, let's take a look at an example. I have this crash course app for us to walk through today. And I have a primitive and a complex example for us to look at. So the primitive example is kind of silly. We have an input that gives me the ability to provide some text. Then I have an output of the same variable here. So if I say, hello, Tampa, you can see that this change that I'm keying in here is immediately being reflected in this as well. So changes tracked. We'll look at the code behind on this, but you can see here, this is immediately reacting to my changes and displaying the output here as it re-renders. Down below, I have a little bit more complex variable, complex UI component. This is a standard component called a tree grid. I have the ability to put in this kind of tree of values here. So I have Jason in Tampa and Ryan in Kansas City. If I want to change some property of this tree, let's say Ryan goes from Kansas City to Denver, I'm putting this in here, and down below, it's immediately reacting to these changes below. So let's take a look at what this looks like in the code. So here's an example of my track component. This is the same component code that we're seeing on the screen here. I've got my two basic variables. I have basic variable, or excuse me, I have my basic variable and I have my complex variable. This is not annotated with track, but as we saw in the UI, it is immediately reacting to changes. And I have a more complex variable that I do annotate with track. And you can see this is an array with various objects inside of it. So here's Tampa and Jason, Kansas City and Ryan. I have a couple event handlers here. So whenever I update this basic variable, I'm taking the update event and I'm assigning it back to this variable here. And in a similar way, if I update my complex variable, I'm grabbing the Kansas City element and modifying it. And that's what this code is doing here. When I take a look at the components in the UI, I've got a basic Lightning input that's tied to that basic variable. And here's my onChange handler that ties out to that change function we looked at. And that same basic variable's here. So as I type in an update, this output of the same variable is automatically reacting to those tracked changes. So these two things are held in lockstep, and it's immediately responding, reacting to, and re-rendering that same variable here. And it works very much the same way down here below. I have an input where I'm putting in that variable. The change handler is assigning that instead of Kansas City to whatever I type in. And then that lightning tree is re-rendering automatically and instantly because those are tracked changes. And so that's the power of a tracked variable and how it can immediately reflect in the UI without having to do a lot of code. So if you're coming from Visualforce and you remember re-rendering and what's in the form, you know, it's way different over here. It's a lot simpler and faster in this regard too. Okay. Any questions on this, Jason? Seems like chat's pretty quiet. Oh, Tyler, see hand up.
Hi. Can we go back to the code for a moment?
Sure.
So and then the JavaScript, if you wouldn't mind.
Okay.
So I was under the impression that tracked variables, like, so when they get changed, they re-render the component. Is onChange necessary for the basic primitive version example in order to get that to update?
You mean in here?
Yeah, is that necessary?
So I'm taking the event of the change and assigning it to the variable. Yes. So you'll have to take the component changes. And
I see. Okay. So okay. Because I think,
So the reactivity of that variable will automatically re-render the corresponding item there. I know this example is a little contrived. Realistically, you're probably not going to be showing the same variable you're editing, but it's kind of used to illustrate the reactivity of track on that.
Okay. So if we are to set something up as track, or if it's a primitive and it's already tracked, and the component re-renders upon that value changing, then we still would need to Okay, because that's okay, because we're taking the value and putting it into a different bucket, if you will. Okay, I see. So if something were to just reference basic variable and it was tracked, and that basic variable was being displayed in the UI, then us changing that we wouldn't need on change for that if we were just displaying basic variable, right?
Right. Yep.
Okay, I see. Okay, thank you.
Okay, let's move on to API here. So API is the next decorator. And API, its purpose is to expose a variable or a function to other components that gets access to it. So if you have an @API annotated variable, it allows you to pass a variable to that component through an attribute of the component. We're going to take a look at that in just a second. The other thing it allows you to do is it allows you to invoke functions that might be hosted in that component as well. Just a quick call out for those who work with managed packages or code packages in general. If you annotate something with @API, it becomes kind of versioned in your application. So you cannot change that at that point. But let's take a look at the @API example. We'll start here in the browser on the @API tab. A couple things are going on here. So again, kind of a silly example, but we're going to do a greeting. So whatever I type here will become hello and then the greeting. So I'll say hello, Jason. So I have a parent component that plays host to this input. And then I have a child component that is receiving the variable from the parent and responding to it. So instead of hello, hello, maybe we'll say hello, Jason. So again, we're using that reactive composition. We're passing the variable that's input from the parent component down to the child. And then also in that child component, I have a function that sends up a JavaScript alert with the greeting, hello, Jason. So the parent component is invoking a function from the child component. Let's take a look at what the code looks like for this. So first off, I'll start with the markup for the parent component API example. You can see here I have a button with a handle click event. I have my input for my greeting, who would I like to greet, and I'm assigning that to the name variable. And then I have a child component with an attribute that's been exposed with API as hello name, and I'm passing to it that same variable that's being put in here. So when I was typing in a value here, every time I change this variable, it automatically tracks it and passes it down to the child component. So that child component's receiving that with every change I make. Taking a look at the code behind on the parent, pretty straightforward, right? So the parent has this name variable here, and I have handle change, and then I also have a handle click from the button. What this is doing is it's grabbing the child component and invoking the hello function. So let's take a look at that child component. The child component has an @API annotated hello name. So tying this out to the parent, hello name is the attribute that I'm making available through @API. And it's available to me because I've annotated this with @API here. Within the component, I have the greeting that I'm creating based on hello and the hello name variable. And then you can also see I have an @API annotated function, not a variable, but a function that's throwing up the lightning alert. So looking at that button click that we were looking at earlier, when I click on the button, I'm grabbing that child component and I'm able to invoke that function because that function is exposed to me through @API. So clicking on this here, it's actually making the child component do the work for the alert here. Okay. So API really just is used to expose stuff and to be sharing information, variables, functions, etc., across various components. All right, let's move on to @wire. Wire is probably the most misunderstood and underappreciated decorator here. @wire it's a reactive data service, and I think probably the best way to explain this is through the demo. But ultimately, what this is doing is it's provisioning new data either from the cache or from the network anytime a variable value changes. This is different than an Apex imperative. So an Apex imperative is basically a call to an Apex method on the server side, and you do that kind of on demand. So we're going to look at an Apex imperative, and then we're going to contrast that to a wired method here in our code example. But the wired service is a reactive data service. So let's take a look at this. And the way that I built this is actually using a Lightning record page component. You can see here my wired example. This is kind of a silly example, but ultimately I have a related list of contacts that are tied to this account. So you can see the same contacts here as you do here. When I make a radio selection here, I have a reactive variable that's tied to that wire service, which is going and retrieving and provisioning data, in this case, the email for the selected contact. So anytime I select a radio button, I'm changing which contact I have selected. The wired service is reacting to that change, and it's provisioning new data that's associated to it. So some key things to call out here. Again, this is a record page component, which means I'm inheriting some interesting information like the record ID and the object type. We're going to look at that in a second here too. But then I'm using this reactive data service to provision data each time I make a change to a variable. Okay, let's take a look at this. So the UI for this is pretty simple. I have a pre-built Lightning radio group component, which is showing some options that we're going to look at. And then I have an output field of the email for the contact that I've selected. So pretty straightforward UI here. If I take a look at what's in this component, there's some more things in here, but it's sort of building on the track and API examples that we looked at previously. The first thing here is that component lifecycle. So as soon as the component is connected, I want it to go retrieve contacts that are associated to this account. So if you recall, @API means expose it to something public, right? In this case, the Lightning app itself is grabbing hold of these public components, public variables with record ID and object API name. And it's providing to me the record ID and the object name for the screen that I'm on, in this case, the account. So the first thing I do is call that Apex imperative. We're not going to spend a ton of time on these because if you've used Apex or you've used Aura, you probably are familiar with these, but I'm importing an Apex method here from a class, wire example service, retrieve contacts. And I'm passing to it the account ID that I received from the record page. So the very first thing I do when the component's created is I query the contacts and I put them in a list for the radio group to show. So that's what this function is doing here. It's putting these into a list of contact options. Okay, so from there, the UI renders, right? We have the radio group that's shown. The big thing that I want us to focus on here is this @wired reactive data service here. So we'll talk a little bit this more about in composition, but we're using a pre-built function to get record. This is available to us as part of the framework. So we're able to use this get record function that retrieves the record in question. What it looks for is a record ID and a set of fields that are interesting. So in this case, I'm passing to it the selected contact ID. And then I'm telling it to go and retrieve the email tied to that contact ID. So here's where the wired service kicks in. Remember, anytime that I selected a different radio button here, I'm reassigning that selected contact ID as a property. That selected contact ID is changing, which tells the wired service to go retrieve new information. So each time I make that selection, this variable is getting updated. And then in response to that, it's querying for that record and pulling in the contact email, which we display in the UI. Wired services are very powerful, but oftentimes misunderstood. And so I think this is a good way to show off how those changes can reflect in data provisioning. We'll look about this a little bit more with composition later, but any questions or comments on Track, API, or Wire before we go any further? Okay, simple enough. Okay, so taking these key concepts forward to some design patterns, and we'll go through some examples on this too. The first thing I'd call out with your design patterns is not to reinvent the wheel. Don't forget to go shopping. There's a Lightning Web Component catalog that has a tremendous number of resources in there. There's a ton of pre-built components that are out there for your disposal. I took a screenshot of this here as a great example. There's a tree grid with hierarchical data, nested rows. This is a pretty powerful component that you see here. And like we looked at in the wired service example, there's also pre-built functions that you can import into your component as well that help with data provisioning and things like that. So the first thing I would tell you is go shopping. Go find out if there's an example already built in the Lightning Web Component catalog that fits your needs and try to take advantage of it. Otherwise, there's a GitHub repository. And again, these are links in the deck that you'll have after. But there's a repository of recipes that's been built by the community, Salesforce developers. They give a lot of showcase development for how to go about connecting different components, component hierarchies, component capabilities, and the like. So these are tremendous resources to use as you evaluate what functionality you should take off the shelf and then what you might need to go build from scratch. If there's only one other thing that you learned today in this crash course session, it's this. Don't build one enormous component. Please don't do that. I can't tell you how many times I've opened up a component where people have complained that it's not working right, that it's flaky, it's buggy, and there's like thousands of lines of code in it. It's doing crazy, weird bananas things, and it's impossible to debug. Create a composition of components for yourself. Have your components be really simple and really good at just the one or two jobs that it needs to do. Don't try to boil the ocean with one giant component. Components can get complex enough in and of itself. So if there's one thing that you learned today, it's don't build one giant component. Figure out how you want to break your components down into smaller, digestible pieces of functionality. And the design patterns that we're going to go through next are going to help reinforce how you can make those components communicate effectively with each other, share data, and the like. Okay, so the key thing for this strategy is communication. And there's really two main styles of communication that I would highlight here. One is communication within a component hierarchy. So in the example that we saw with our API decorator, we had a parent component and a child component. The child component had that public property, and the parent component could pass information to it or even invoke functions from the child as well. So those components can talk to each other through @API annotations and through custom events, which we're going to get into a little bit more. So this component hierarchy is very vital for the communication of components and really focusing on having the components do their job only and being good at that and deferring other aspects to other more focused components. The other main type of communication that we'll go through is stuff that you'll see in a Lightning app page or a Lightning record page. These are when you have components on the screen that are loosely coupled. They might be interested in a change from another component. So let's say that you have data that's updated in one component and you have an interested component on the other side that might need to hear that change and respond to it appropriately. There's a lot of demos and things like that out there from, if I change an address, the map should update automatically next to it. So there's some good things out there as examples. You could take a look at the recipes too. But I think I would just sort of boil this down into like loosely coupled components that should have the ability to talk when they need to. And we'll go through some examples on that too. So the first thing that I want to talk about is probably the more common mode here, which is a hierarchy of components. So again, just like the API example that we talked about earlier, you have a parent component with children or many children or even many layers of children. This is a very common design pattern, having a component hierarchy here. Some best practices to call out for this component hierarchy is that all your data or all your state should be held at the topmost level of the component hierarchy. And all that data or all that state should be passed down from the parent to the children. This is a best practice because of that reactive property that we have with @track and @API. So if you have one sort of version of truth at the parent, and that's passed down through reactive variables throughout the entire hierarchy, everybody's working with the same copy of data, and any changes to that data will permeate the entire tree automatically and instantly. So this is a key consideration here. You know, to compare that to another approach, if each component in the hierarchy had its own copy of the data, it becomes a lot harder to manage. Like, what is the source of truth? You know, how do I share that data across those components? It becomes much more messy. So the best practice is to hold it up at the top level. Every component should have its own isolated purpose, like we already talked about, and be really, really good and focused at that, and defer whatever it doesn't need to some sort of orchestration at the top layer or whatever that is. As you might imagine, this is ideal for more complex functionality. You're ultimately designing a series of components that are working in concert with each other, and oftentimes lends itself to more complex use cases. So I've worked kind of a sample example of hierarchy here for us to discuss. So let's take a look at sort of a diagram of what's happening. We have a pipeline manager component, which is going to be our parent component. We're going to look at the code here in just a second. I have an opportunity data that's being created and held up at the parent. And then I have data that's being passed down to child components, one that shows your list of opportunities, and another one that shows the total value of all those opportunities. Any changes that we make to those opportunities are going to bubble up to an event handler, which will then update the data and then immediately reflect down through the component hierarchy again. So let's take a look at this example here in the UI. So here's our pipeline manager. This is presenting a list of all of the open opportunities that I have here in this instance of Salesforce. So this is a pre-built Lightning component. This is a Lightning data table. It sits as child to the pipeline manager. And I'm able to look at these, and I'm also able to edit, in this case, the fields. I also have that pipeline total component, which is down here. And all this component is focused on is showing the formatted currency of the total amount of all these opportunities. Let's say that I was talking with United Oil Plant, and they got really excited about the opportunity, and they added a bunch of new products. So let's say this opportunity got quite a bit bigger. When I tab out of this, I'm capturing an event that would update the data for this opportunity, and it will automatically reflect that new total down here at the bottom. So as I tab out, I'll see that this amount immediately changes to go along with it. And let's say on the flip side of that coin, you know, the deal kind of deads out and there's no value to it. Again, as I make changes, it'll immediately go down and be tabulated into this total here. So let's take a look at how we can design these components to work together in this hierarchy to create such a quick reaction to this total calculation here. So looking at our pipeline manager, it's very basic, right? We have two components here. We have our pipeline opportunities, which is that data table. As you might imagine, I have my @API annotated opportunities variable here. And I also have an on total calculation component, or excuse me, event handler. We'll look at that in just a second. The other component that I have here is our pipeline total, which simply gets the total passed down to it. So all my data is held at the top level. So I have my opportunities and I have my total here from the top, and it's passing that data down to the children. In the same way that we created our wired example where I'm retrieving contacts, I'm again using the connected callback to retrieve opportunities when the component is created. So I'm invoking a Apex method here, which is returning opportunities to the page, and then I'm assigning that to my tracked variable. So as soon as those come back, the page reacts and shows all those opportunities in the list. The other thing that I'm doing here is I'm handling a total calculation. So remember, we're letting that child component do some things that are interesting and then emit changes up to the parent. So when that change occurs, we're listening for that. Handle total calculation. So here you can see the event handler here. And then I'm assigning the total variable based on the event that's bubbling up from the child. So let's take a look at the pipeline opportunities component. This component, as you can see, is exclusively focused on rendering that data table. So it's just the one pre-built component here. A few attributes are assigned to show the data, row number, column, etc. And then I have an on-cell change. So if you recall, when I edited this, I have an event handler that listens for that change and then is used to emit some interesting information back up to the parent. So looking at the code behind on this, I don't want to focus too much on this because this is more about the Lightning data table, but I have a set of columns that I have to define for what is rendered here. So you can see name, stage, close date, amount. Again, how that ties out here. But I'm passing in those API annotated opportunities. That's how I'm doing this with that component attribute. So I'm setting the data property in this component to those opportunities that are passed in. And when that gets set, I'm doing a calculation here immediately on this. So let's take a look at that function here. So anytime I get those opportunities passed down to me from the parent, I'm doing a calculation of what the total is. And then I'm emitting that total back up to the parent. So it's telling the parent what the total is based on the opportunities that it received. So at that point, the grid is rendered. All the data has been passed down and the total has been emitted back up to the parent. That handle change event, if you remember when I tabbed out of the cell, on cell change, we're invoking this function here, handle change. And what I'm doing is I'm parsing the amount out of the event. I'm decrementing the old value of what the opportunity was, and I'm adding the new value from the event that just occurred. Last but not least, I'm emitting the new total. So as soon as I've recalculated the total based on this changed value, I'm emitting that total back up to the parent. And that's why we see this change immediately after I make this edit here. So if I change this to 5, again, you'll see that change show up on that. So all this is happening very, very quickly, but it's being managed through this reactive set of variables that we're passing down from the parent. And then those events that we're observing, like the new total, are being passed up and then reflected down immediately into the other component. Taking a look at the pipeline total component, this is a really, really simple component. I'm showing a formatted number here in the UI. And although there is a code behind, it's about as simple as it gets. I have one @API annotated total variable. So I'm able to pass that down from the parent. And this component can be exclusively focused on just showing the total here and floating it off to the right. So all the styling and everything else that I might need to do to this total component is really handled here. And it needs to only understand the data that's being passed down to it. Okay, deep breath. I'll pause here. Is all this kind of making sense in terms of how the component hierarchy works together, the advantage of holding the data at the topmost component, and the reactive variables that are passed down through the child components? I love thumbs up, Jen. That's great. Thank you. Okay. Let's move on. So the other scenario I would really talk about here in terms of composition would be those loosely coupled or more independent components that are out there. These components coexist. They oftentimes operate autonomously. They should not be dependent really on the other component being there, right? Something to call out here is a wired service is your friend here. So if you ever need to share some updated, interesting bit of information with another component, those are great candidates to tie to a wired service. So if you need to go pull in new information or do some server-side thing based on an update, wired annotations are really, really great for these loosely coupled components that need to react with complex interactions there. This sounds a little bit silly to call out, but these components can sometimes get chatty. And so it's best if you talk when you need to and be quiet when you don't. Sometimes, I look at components and they are really, really chatty, and it can become difficult to try to debug what's going on. Or you see logic that's introduced to basically filter out events that are of interest to another component, and that can get messy. So try to limit the amount of talking that happens so that it really can be focused. We're going to talk about the Lightning message service and a more recent addition to the Lightning Web Component Framework, which is my favorite, the dynamic interactions. But really, this type of composition, this independent composition, is best suited for record pages, app pages, home pages, that kind of thing. So let's talk about the Lightning message service here. We're not going to have an example of this, but hopefully this diagram and this kind of shows how it would look like in general. But the Lightning message service was really designed from the ground up to help communicate across the entire Lightning app ecosystem. So it allows you to communicate with Visualforce, with Aura, with Lightning Web Components. You define a message channel, which is kind of like an event or even an object with the custom metadata that's associated to it. A component will publish a message to that channel or to that event bus. And then other components can subscribe to that channel, hear those events, and take action on them if needed or if necessary. There are some limitations to the Lightning messaging service. Doesn't support iframes, doesn't work in Salesforce Mobile, doesn't work in Salesforce Classic. So some things to kind of think about there. This is very reliable, tried and true. My personal opinion, it's a little heavy. And so to that end, I tend to favor dynamic interactions. And that's going to be the example that we walk through today. But I at least wanted to make sure that everyone is aware the Lightning message service is there. It's great, but it is a little heavier handed. The other way for disparate components or loosely coupled components to talk to each other is through dynamic interactions. And that'll be our example that we go through today. What I really like about dynamic interactions is that the components have an event that can be defined by a developer, but they can be configured by administrators. And so we'll look at what this is in the Salesforce UI here in a second. But these components are allowed to talk directly to each other in the same way that we saw components talking to each other with custom events in the hierarchy example. So with that, let's jump over to Salesforce and take a look at what these loosely coupled components can do with each other. Again, this example is a little bit contrived, but bear with me here. I have a simple on-off switch here, and I have a listener component that's over here. This page is a app page with just a left-right kind of orientation. So we'll look at this in the configuration here in a second, but these are two truly independent components of each other. If I toggle this on, I go on and I have a timestamp of when that occurred. I can toggle it off and back and forth and back and forth. So you can imagine how you could leverage a component that makes a change and have another component that's interested in it, but still autonomous of it, react and do things appropriate to that change. Let's take a little bit of a look at how this is configured, and then we'll take a look at the code that sits behind it. So here I'm in the Lightning App Builder page. and I have my left-right split for this app page. I have two components here, the sender component or my toggle component, and then the listener, which is my icon component that we have here. The big thing to take a look at here is when I have this sender component selected, the toggle, I have this interactions tab that shows up here. We'll look at how this is configured in the metadata here in just a minute. Ultimately, what this interactions is letting me do is say, when a certain type of custom event is sent out by this component, I want to target a component to deliver that to. In this case, in my right region, my interaction icon component, which is here. So I'll select that. And then I have different properties that I can assign to it. So I have a status of on, off that I want to pass. And I also have a timestamp that I want to pass. So what I'm doing is I'm indicating which events should be heard, where those events should be delivered to, and map to that component what the payload's properties are. If I take a look at this, I have some attributes that are the status and the timestamp, but having these exposed here allows me to also assign them through this interactions that are created here. So really powerful stuff, quick kind of focused interactions between components. And the icing on the cake is that an admin configure and reconfigure these based on their changing needs as time goes on. So let's take a look at the code that sits behind this. We have our interaction toggle component. This is a really simple UI, right? So we have a lightning input that's of a type toggle. I have on-off for the active and inactive states, and the value of this is being assigned as status. Anytime there's a change to this, I'm handling the change. So let's take a look at what this is. In my connected callback, I'm setting a default status of off. And then anytime I have a interaction with the component, I'm tying this to that handle change function, and I'm dispatching an on-off event for that toggle. The payload of this event is of our own creation, and I'm passing the word on or off based on whether or not the toggle is checked or not, active or inactive. I pass on or off. I'm also passing the current timestamp for when this occurs to pass over. So in the same way that we're dispatching an event in the component hierarchy, we're dispatching an event here. It's just that this component doesn't have anything that's listening to it. There is some additional configuration that we need to have to support this. So we talked about lightning targets earlier. So this has a lightning target of an app page. And then within that target config, I'm also able to specify an event for the dynamic interaction here. So this on-off event corresponds to the interaction details that you see here. So the description, status, timestamp. This is all being sort of demonstrated through the properties that are in this components definition, metadata definitions. So the same values that you see here, status, timestamp, the description of it, that's what shows up in the app builder declarative UI here. So that's what this component is doing. It's simply doing on and off, and then it's emitting event for anyone that's interested in hearing it. Taking a look at our interaction icon, again, very simple, straightforward component. I have a lightning icon that I'm showing. That was our sleeping or sunlight icon that we're displaying. And then we're also displaying the timestamp that comes through from the event. Again, using the @API annotation. So this exposes these properties as public so that we can assign them through an external caller. But really simply, whenever the status changes, I'm switching which icon name I'm returning based on this. So I'm passing on or off based on the toggle state. If it's on, I return the sun logo, which is custom 3. And then I return sleeping if it's off with this waits icon here. The one last thing that I'll call out that you need is this property configuration here in the metadata. When I expose these properties, status and timestamp, they show up here for the admin to configure here if there's a default. You can even make these dynamic, tied to pick lists, etc. There's documentation on how to do that. But exposing these here also allows me to define these interactions that work with the component on this.
So, hey, Ryan, while we're here, one question that came in from the chat was, how would I configure this if I had two listeners that were listening for that sender?
Two listeners for
Like I
that.
had, like I say, I have like say I have two different components that are listening for that on-off event.
Yep.
How do I configure that with the interactions? You just add a new interaction.
Yeah, so you would click on the component that is emitting the event. You would click, and I've already got this one configured to send
For
it
the
to
one, so
but
right.
if
So
I wanted to send it to another component, then I would basically go through here and choose
set up
the
another one. Yeah. So it's
Yep, you
so
got it.
you're explicitly setting up the communication versus the listener just listening for the fact that something happened.
You're right. Yeah, it's a directed delivery of that
Gotcha.
event.
Gotcha.
So if I created this new interaction, then I can see, okay, you know, I can pass this to the interaction icon, which is in my right region. And then
Yep.
I can see, again, like, here's my event dot status. That's how I configured the first one. So you can deliver this custom event to as many listening components as needed.
Yeah, so it's more of an explicit communication, and the nice thing with this too is the admin who is setting this up can say, well, I want this one to listen to that sender, but
Yep.
not this other sender. So I could have multiple instances of this same sender class on there that are sending the same event type with the same packet with the same event, package, and I can say I want listener one to listen to sender one and listener two to listen to sender two, but not any other interactivity. So that's pretty neat.
Yep. I think this is it's great because it's directed. You know, the message service is a little bit like drinking from a fire hose sometimes.
Yeah.
Yeah. Man, time flies. Wow, we're right here at the hour here. I will follow up with the deck that Jason can distribute. I guess just any other quick questions before
We did have one that I held off till the end.
Okay.
There was a question about can when using the targets for an LWC component, is it possible to target that to a global action, like a global quick action button? I looked it up while we were having the conversation, while we were having the event here, and it looks like you still have to wrap it in an Aura component. Hopefully at some point Salesforce will change that, but I didn't know if you were aware of anything newer than that.
I'm not on
Okay.
that. Yeah.
Yeah, I just want to, sorry, hello. So I just want to ask that question because when I create a global action, I find it possible to select Lightning Web component, and I tried to add my component and it was added. But whenever I try to add it to the layout publisher, I never find it in the global action. So it's just weird.
So when you're talking about up here in the global
Yeah, exactly.
yeah,
well, when you go to set up a global action and then you create new global action, it's possible to select Lightning Web component, and then you can select the Lightning Web component that you targeted to a global action. But then when you add it to the publisher, you never find it in the list of the options.
This does ring a bell. We ran into this for our own internal instance.
Yeah, and I think we had to wrap it, I think.
I think you're right.
Yeah.
I think we did have to wrap it. So
yeah, I was just wondering, why is it possible to add it if we also have to wrap it only? That was my question.
Yeah. I'll double check on that. If I find anything, I'll have Jason reach out with some information. So
yep, absolutely.
Thank you.
Okay. Yeah, I posted in the chat. Thank you everybody for joining. We are over time, but if you do have any questions or anything that you wanted to bring up, feel free to continue. We're flexible here if you have any other questions. Otherwise, we can call it a session. So.
I have a question that's not related to LWC, but is more of a developer-y sort of question. I've been looking at IntelliJ and JetBrains, and I'm wondering if what your opinions on it are compared to VS Code, I guess, or really anything.
So, you know, IDEs are a little bit like religion sometimes. You know, it's what you
I'm willing to
want.
convert.
Yeah. And VS Code is a great tool. And if you're doing things like custom Salesforce CLI plugin development, there's some tooling that's built in VS Code that's, as far as I know, at least right now, exclusively available in VS Code. That said, you know, I think it really kind of comes down to personal preference. For me, I really like IntelliJ, and it's coupled with a tool called Illuminated Cloud, which is a paid Salesforce plugin. You can use a community version of IntelliJ, so you're not paying for that. But it does have some limitations in there. For me personally, IntelliJ is my tool of choice. I think it transitions really gracefully between, you know, polyglot development if you're doing anything outside of Salesforce, and then of course going back to Salesforce. But frankly, so is VS Code. Just for me, my brain seems to work better with the menus that are in IntelliJ, but I like VS Code too. It really just comes down to personal choice.
Is illumination necessary for getting the same like extensions that you would use in VS Code for Salesforce?
Yeah, VS Code is has the free Salesforce plugins to it. Illuminated Cloud is a paid plugin. I want to say it's like $100 one-time purchase, but
It's a one-time purchase? Okay.
I think it is. Yeah.
I thought there was a yearly renewal on that. I'm not sure. In any case,
that's a good thing to check. You know, I think maybe the one-time purchase was the first version of Illuminated Cloud, because I think Illuminated Cloud brought on all the DX support. So you can't go wrong, I guess, is what I'm saying. And then of course, I just have my own personal preference here.
No, understandable.
yeah. I mean, I came up doing C# development, so VS Code is is Visual Studio basically for me, So I felt once I was able to move off of I blocked it out of my mind because I never want to talk about it again. The JavaScript anyway. Once I was able to move off of that onto VS Code, I was like, oh, okay, I'm back into what I recognize. But yeah, and I like it because it's free, because I'm cheap. But yeah, and I agree. I think somebody else posted in the chat. I made it a point to learn the CLI commands and not rely on the plugins. But the plugins are nice, but ultimately, the more you can remember, the better off you are. So
yeah, definitely agree on that. Yeah,
that's
having that handful of 5-6 commands that you need all the time would be great. So
yeah, I do that with GitHub, with Git as well. I'm like, it's easier to type it out than to try to use the UI a lot of times. So
I hope to get to that point someday. But thank you. That answers my question.
Okay. Any other questions or? Okay. All right. Well, again, if you have anything you think about it after the session, feel free to reach out. And this is being recorded, so I will post it out on YouTube once it's done, and I'll update the community group page with the links and everything. So again, Ryan, thank you so much for your time. Appreciate it. This was a great session. Appreciate everybody's joining in, and made it a great session. Thanks, everybody. Have a good weekend, and talk to you on the next one. Thanks.